Assalamu alaikum, dear students. This class is for 12th. Subject is chemistry, and our today's topic is from the D block elements. In this topic, we will study the magnetic properties of D block elements and the interstitial compounds. So, first of all, we will know about the magnetic properties of these D block elements, जिनको हम ट्रांजिशन मेटल्स भी कहते हैं. As we know, these transition elements they also form colored ions due to their this d electronic configuration. There are various substances which show magnetic behavior also. We have substances that are attracted by the magnetic field are called paramagnetic, and the phenomenon of attraction of the substances by the magnetic field is termed as paramagnetism. This paramagnetic property is shown when the substances have unpaired electrons. That is, paramagnetic behavior is shown by those elements or by those substances which have unpaired electrons. That is, their orbitals are not completely filled, or we can say they have only one electron in the shell, these orbitals. Paramagnetic property is only shown when the substance contains one or more unpaired electrons. When a substance acquires a permanent magnetic moment, it is known as ferromagnetic, and the phenomenon is called ferromagnetism. So, as we also know, magnets are of two types, that is temporary magnet and permanent magnet. When any substance attains the magnetic moment and it acquires a permanent magnetic moment, at that time the magnet is known as ferromagnet, and the phenomenon is called ferromagnetism. We have substances also which are not attracted by the magnets but are repelled by the magnetic fields. Those substances are called diamagnets. So we have three categories of substances here. That is paramagnetic, which are attracted by the magnets, diamagnets, which are diamagnet, which are repelled by the magnetic field, and ferromagnet, which attain permanent magnetic moment. A substance shows diamagnetism when it contains only paired electrons. Most of these elements, transition elements, they show paramagnetic behavior due to the unpaired electrons. And the unpaired electron in n-1 d orbitals are responsible for this magnetic behavior. The paramagnetic character of the transition metals increases when we go from left to right, from scandium to zinc in the first transition this series, because the number of unpaired electron increases from 1 to 5 and then from 6 onwards. The middle elements are found to possess the maximum paramagnetic properties, and the magnetic properties decreases with the decrease in the number of unpaired electrons. The transition metals which contain paired electrons depict diamagnetic behavior. They are repelled by the magnetic fields. And now we will try to explain why these elements show this magnetic behavior. An electron is a charged particle which revolves around the nucleus and spins on its own axis. That's in a particular path, in a fixed path. A magnetic field is generated due to the orbital motion of the orbital motion and spin motion of the electron. There are two motions. That is, one is the this electron revolves around the nucleus, and second is it spins on its own axis. Due to these two motions, the magnetic field is generated there. The spinning of an electron in an orbit is very much similar to flow of electric current in a closed circuit. Therefore, an unpaired electron is regarded as a micromagnet which has a definite magnetic moment. A substance which contains an unpaired electron when placed in a magnetic field interacts with the applied field. An attractive force is exerted and the paramagnetic property is shown. The number of unpaired electrons determines the magnitude of magnetic moment. More the number of unpaired electrons, more is the magnetic moment of that substance. Higher the number of unpaired electrons, more is the magnetic moment and greater will be the magnetic behavior of the substance. In the case of paired electrons, the substance will act as diamagnetic. The electrons in each pair will have opposite spin. That is, the total spin, or we can say the one is in the upward direction and another is in the downward direction, or one have plus 1 by 2 spin and another have minus 1 by 2 spin. So the net magnetic moment at that time is zero. The magnetic field created by the electrons of same pair is equal and opposite in nature. Hence, the magnetic field which is created by one electron is cancelled by the other. So, the net effect of magnetic moment is zero. These kind of substances show diamagnetic property and are repelled by the applied magnetic field. This is about the magnetic behavior of these d block elements. Now, what are interstitial compounds? Interstitial compounds are formed when small atoms of hydrogen, carbon, or nitrogen get trapped inside the crystallites of metals. So, interstitial compounds, as we know, interstitial sites, these are the places between, these are the places in between this, we can say, in a crystallites in a particular structure. When there are small spaces, these small spaces are called interstitial sites. So likewise, when the compound, small compounds like hydrogen, carbon, nitrogen, when they get trapped inside the crystallites, any structure of the metal, and that is known as interstitial compound. A number of interstitial compounds are formed by the transition metals. Transition metals react with elements such as hydrogen, carbon, nitrogen, boron, etc. to form interstitial compounds. As we know, these vacant spaces, which are also called interstitial sites of the transition metals, are filled up by the small atoms. These compounds are hard and rigid. The chemical properties of the parent transition metal, in which these get we can say embedded, or we can say these uh, get inserted, these small compounds of the parent transition metals are not altered during the formation of interstitial compounds. So the properties of the compound are represented by the property of the main element, that is the d block element. However, there are various changes in the physical properties such as density, rigidness, hardness, malleability, ductility, etc. Steel and cast iron are the interstitial compounds of iron which are formed with carbon. In the formation of these compounds, the malleability and ductility of iron are lost to a great extent, but the tenacity of the metal increases. Transition metals have crystals which are either hexagonal close packed or face centered cubic structures. These we have already these structures studied in our this solid state. Both of these lattices are very similar and have two types of holes. First, there can be two tetrahedral holes per metal atom. That means there is a hole between four metal atoms. A hole between four metal atoms. And there can be one octahedral hole per atom. That is, the hole is between six metal atoms. These compounds have very high melting and boiling point is higher than that of the parent transition metals due to the small compounds which have been inserted into the crystal structures. These compounds are very hard. The hardness of some borides is comparable to that of a diamond. The conductivity exhibited by them is similar to that of parent metal. These compounds are chemically inert in nature. These compounds are chemically inert in